Okay, guys, these are the last set of notes for this particular pie slice on triangles. And this, well, what did I just do? Yikes, Control Z. What did I just do? Let me try this. Okay, there we go. Well, that was wild. I like shrunk it down so tiny. Okay, anyway, this is the last video notes for this particular pie slice. It has the rest of them on here. Okay, and this particular one has to do with what we studied on Friday, the notes I gave you. Remember, words mean everything. Okay, so you should know what perpendicular bisector means. It means it cuts it in half. So if you have something, whatever it may be, if it's a segment, well, it should be a segment, it's going to cut it in half at a 90-degree angle. And then these two pieces are going to be equal. Okay, an angle bisector literally means it cuts it in two. It's bisecting an angle into two equal pieces. A median is something you might need to memorize. A median is a specific segment. It goes from the vertex to the midpoint. So if you have a median, those two sides are equal. Okay. And all three medians meet at the centroid. Okay, the altitude, the main thing about an altitude is that it is always going to be perpendicular. Okay, so that's the main thing. You can't guarantee that these are going to be equal on the altitude, but all right, so take a look. Okay, this is basically just a vocabulary test. Can you recognize what that is? And the answer is it's an angle bisector. See, it's cutting it into two equal parts. Look at this one. See how it's not measuring the height of the triangle because it hits here and it's cutting it into two equal pieces. That is a perpendicular bisector. Next, I did a bunch of these. You can always pause, try them yourself and see if you get them right. Okay, here we go. Try this one. Again, look at it. It's not going to the apex, two equal pieces. Here you go. That is a perpendicular. It's the perpendicular part. And this is the bisector part, okay? This one, HI, okay, it's not the perpendicular bisector. Yes, it's perpendicular. Yes, these look equal, but this could be 10.1 and this could be 10.12, not equal, okay? It's not the angle bisector because there's nothing here. It's not the median because we don't have equal parts here. However, it is the altitude, okay? Next. Take a look at this one again. Okay, angle bisector. I hope you got that right. And this one, altitude. Okay, you can see because nothing is marked. If this had been marked with these little marks, then we'd have a whole different answer, but that's not what we have. Okay, all right, next. Now you're going to be using these points of concurrency. Say that to yourself. Points of concurrency, where these particular segments meet. They all meet at a special point at different points. And those are what I gave you on Friday. Okay, consider triangle ABC in the figure below. The perpendicular bisectors of its sides are. Okay, so it's telling you. Now, what it isn't doing is giving you the rest of the segment. Like when we constructed it, we had that whole piece sticking up. They eliminated that, which is kind of nice. And now I just realized I need to lock this down. Lock it down. Lock it down. That's not the right one. Lock it down. Okay. So, lock. There we go. Okay. So what you have here, now look at these. Don't say that these are equal. They don't even look equal, okay? That is not what this is doing. It's meeting here. Remember, if you remember, G is the circumcenter. What does that mean? It means you could hypothetically draw, I won't be able to draw this, by the way. You could hypothetically, oh my God, I really can't draw it. I tried. It doesn't work. Okay. Basically, you could draw a circle. Oh my God, I'm not even going to try, you guys. Okay, around this triangle. What that means is that this is congruent to this is congruent to this. That's what they expect you to be able to know, you guys. They expect you to know that all three of these hypotenuses of these triangles, do you see the little triangles, guys? Do you see? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh man, there's even more triangles than that maybe. Okay, but they want you to know that these segments are equal, and now they're gonna give you the other segments. So you need something to write on. I suggest that you copy this, okay? That you just copy this triangle on a piece of paper, okay? You draw the thing in the center. It doesn't have to be perfect. Look, at mine is definitely not perfect. Okay, I'm marking it. Try to draw a perpendicular as best as you can. And then what they're going to tell you is they're going to give you measurements. And that's what you want to write in there. So EG is 60. Boom, 60. AB, woo, this big long thing. Okay, AB is 86. Not the little piece, the long piece, okay? And AG is 100. Okay, now what do you have here? Again, look for these, what I'm calling the dominoes, right? The little pieces that are going to tell you other things. Okay, first of all, you would know if this is 100, this is 100, and that's 100. I don't know if we need that. Okay, I'm just saying that it's there. Okay, if this is a perpendicular bisector, they told us it was, and this is 86, that means the little side is 43. That's what they expect you to be able to say. They're like, oh, okay. They give you the whole thing is 86. The whole thing is 86. Make sure that I make that apparent. Okay, and then the little piece, this piece is 43. Okay. Then it says find AF, BE, and CG. So AF, where's AF? AF. So AF is 43 because it's half of that. Okay, BE. By the way, see we don't have to put segments on top when we're when we're using equal signs. BE. Oh, what's BE? How are we gonna find BE? They didn't just give it to us. Now we got to actually use our brains and figure this dang thing out. How are we gonna do that? And CG. Okay, CG's easy. Okay, CG's easy because it's 100. CG equals 100. But how are we going to find this one, the one that we need, which is BE? Here it is, BE. They want us to find BE. Okay. Well, the only way you can do it is you have to realize we don't have this side. They didn't give us this side. We have no way of figuring this out either. The only thing we have we can fill in is we can say that each one of these is 100. Therefore, this is equal to that, but look, we have a triangle and it's right. So you have a right triangle. I'm hoping your brains are kicking in right now with what you need to do. You have 60, you have 100, and it's asking you for this side, BE, okay? I'm hoping that right now you're thinking, oh my gosh, I can use the Pythagorean theorem. A is BE, 60 squared equals 100. Remember, C is always the hypotenuse. And so that equals 10,000, I believe. 60 is 6 times 6 is 36. Add the 2 zeros. And then BE squared. Okay. You guys can do this on your calculator. I will not be doing, I don't know, maybe I will be doing this by hand. Let's see. So I get BE squared equals, subtract 3,600 from there, and I will get 6,400. So this can be done by hand. The square root of 64 is 8. Square root of 100 is 80. If you guys didn't know what I did mentally, I did this. That's the same thing as the square root of 64 times 100, right? 6,400 is 64 times 100. The square root of this is 8, and the square, well, once I pull it out. sorry, that's bad math notation. So this could be the square root of 64 times the square root of 100, and that's equal to 8 times 10. 80. That's where I got that. So that's how you're going to get the last one. Okay, try the next one. Take a look at it. I recommend you pause and try to figure this out on your own first, just because it might benefit you. Let's take a look. I'm going to go ahead and zoom in. So I'm not going to redraw it. I'm going to go ahead, although I do recommend, I would do it on my paper. If I were taking notes, I'd 100% write this down. Okay, consider DEF. There's perpendicular bisectors again, so it's the same thing. Okay, and they'll tell you it's the circumcenter. So look at the picture. You can tell these are not equal, so don't go there. These are equal. When you see circumcenter, you need to realize that's the equal piece. YW is equal to 32. Trying to make it nice, you guys, for some reason, it's just not writing for that great. 32, there we go. DE, okay, this is basically the same problem, is 104. Alex does do that a lot. It repeats things. Okay, and FW, whoa, I didn't want to do that. That's weird. What did I just do? That was weird. Okay, I don't know what I did. Delete that thing. Delete. Okay, this right here is 68. So again, you are going to have to use your brain and figure some of these out, okay? What is EY? EY. Okay, they're looking for this piece. Okay, well, EY is made up of this triangle, so let's take it out. You can always take out the triangle. Okay, this is the point E, this is Y, and this is W. This is 68 because that's 68, so this is 68. And this is 32. And then this is EY. So again, you can use your calculator. EY squared plus 32 squared is equal to 68 squared. Then subtract the 32 squared. You guys, I'm going to show you how you would do it if you were doing it in an advanced math way. You don't actually key it into your calculator yet. You leave it like this, and then you take the square root of both sides, EY, so I have to equals the square root of 68 squared plus 32 squared. And then you put this into your calculator. That way you do all the easy work without actually having to deal with really big numbers, okay? And if you do that into your calculator, then you will get the correct answer for EY, okay? What else are we looking for? DW. DW is the same thing, so DW is 68. It's the same. It's the radius of the circle that could be circumscribed. ZE, and by the way, there's no shortcut. Sometimes you just have to learn stuff. Like you just have to memorize things, okay, or recognize them in the picture. So this is 104, and they want ZE, which is the half of that. So ZE equals 52. I encourage you not to just try to be like, oh, okay, what they did was they half that. Like actually understand that that's a perpendicular bisector. That's the best way to understand these problems. Okay, not sure why that went to 60%, but there we go. Okay, the angle bisectors of PQ whatever are PQR. Okay, so what they're telling you is they just constructed the angle bisectors. So what I can do is I can actually write in here. And if I were you guys, I'm going to do it once. I would copy it. I would write it on my paper like this, okay? And I would try to angle bisect that a little bit, and a little bit. Okay, it's hard, and it's okay. It doesn't mean you have to be perfect. It's just the idea, okay? So that you can write on it. Okay, so remember, angle bisectors give you the incenter. So this is the piece because this is where you can inscribe that circle. I know that's ugly. Okay. I'm sorry, I can't handle the ugliness of my circle. Okay, but that's the idea. See, it tells you it's the in center. And remember, you guys can use your notes. So it's not like you're trying to make this like a memorization problem. Okay. All right. So that's the in center. So it says suppose WZ. So trace it here. WZ is 16. Here it is. WZ. Okay. PZ is 19. PZ is 19. Okay. This is P. All right. And the measure of WPY, remember when you have an angle, that's the vertex. Okay. WPY. Okay, the measure of WPY, that means the whole measure, you guys, not half the measure, the whole thing. The whole measure is 44. I'm going to put it in the middle so we don't think that it's one of the little angles. And the measure of YRZ, okay, so now they're telling you YR, remember the middle is the vert, look, now they're giving you one of the smaller ones. That is 16, okay? 16 degrees. All right. So now I've labeled everything. Now let's just find the parts they want. YRX, okay? YRX. They want the big angle. So your thing is that you need to know that this was the bisector. So the whole angle is angle YRX is equal to 32 because 16 plus 16 is 32 degrees. Measure of XQZ. X, do a little different color. X, Q, Q. Oh, there's Q. X, Q, Z. They want this angle, okay? So how are you going to get that? They didn't give that to you. I'll come back to that because you got to think about that for a second. And XZ, they want XZ. Well, the reason why they didn't give you WZ, they gave you WZ and then they asked you XZ because they wanted you to know that they're the same. So XZ is equal to 16. Now, what the heck? How are we going to get this? Okay. Well, you have something at your disposal. You have 44 degrees here. You have 32 here. You have a triangle, a large triangle. What do you know about all the angles in a triangle? They add up to 180. I'll just call this angle XQZ because that's what it is. Equals 180. Yes? All you have to do is add these together. 76 plus angle XQZ equals 180. And then you're gonna subtract. That's 104 XQZ. Done. Oh, wait, that's not right. Oh, that's not right. You guys, I hope you figured out that I was wrong. What I'm finding out is not XQZ. What I'm finding out is this angle. This angle is 104. I should just call that angle Q. Okay, so sorry about that. Get the idea? Boom. Q, angle Q. Angle Q. Okay. All right. So I could have called it RPQ, but the point is it's 104. So our measure, angle XQZ, is going to be half of that, 52 degrees. All right, let's try the next one. Again, pause it. Space. Okay. Pause it if you need. Oh man, I don't know why it's being so small. Okay, again, angle bisectors, guys. So I'm going to go ahead and zoom in even more. I think I can zoom in with this tool. Not sure why. Oh, I can't zoom any more than that. Okay, so I'm going to go ahead and mark this one. Okay, RS is 18. RS is 18 right here. Okay, I'm underlining as I finish. FS is 27. 27. Measure of PER is 36. PER, the whole thing, is 36. QFS, 58. QFS, this little guy, is 58. Find QFP. Okay, so let's do that. Find QFP. QFP. It's going to be double that because these are angle bisectors. So 58 times 2, which is 116. The way you do that quick, you guys, is you just go 2 times 50 plus 2 times 8, which is 16. So that 2 times 50 is 100 plus 16, 116. All right. PS. PS is going to be the same thing as this one. So PS is equal to 18. Okay, and lastly, QGS. QGS here. So again, you're going to have to use your 180 rule. We have the large angle at the top is 116. This one here is 36 plus EGF, if you will, angle EGF, the big angle, is equal to 180. You add these together, 6 and 6 is 12, add the 1, 50, 152 plus angle EGF equals 180, angle EGF equals 180 minus 52. The way I do this personally is I say, well, 50, I don't know how to explain it. That's funny. It's 28. I kind of say what adds to 7, the number below this one. It works. Yeah. Yeah. Sorry. It's 28. That's the big one, though. Remember, we found the large one. We need to find the little guy. So you divide it by 2, and that's going to be angle QGS equals 14 degrees. If you need to watch this twice because you don't understand what I did, do it. That's okay. There's no shame in watching it twice or watching it in slower. If I talk too fast, slow me down. Use the little gear thing on the bottom, slow me down. Okay, here's the centroid. You guys, remember, what is unique about the centroid, and you should mark it as soon as you get it, is that it's bisecting. This is the midpoint. Every single one of these is the midpoint, which means these are equal, and then these are equal. That's what makes this unique. Also, this is cut into 3, can be cut into 3 equal pieces. Like if this is 1/3, 2/3, 3/3. Okay, that's what's unique about it. So they're going to give you problems like that. So let's see what we got. Okay, centroid, they're just explaining what the drawing says. Suppose BG equals 6. There you go. CD, the whole thing, okay, the whole thing equals 30, and GE, that's this piece here, equals 4. Find GD, AG, BF. All right, so here's the ones I was telling you about in class. This is the thing you figure out. You have to figure out what is the 1/3. Okay, so think about this, you guys. If you have 3 people, okay, and you're dividing cookies between these 3 people, okay, this is 2/3, that's 1/3. Okay, that's kind of the situation. So let's say, in this case, like CD, that there are 30 cookies. Okay, the question is, how much does each person get? They're going to get 10, right? How did we do that? 30 divided by 3 is 10. So you need to divide by 3 or multiply by 1/3. Get it? You're finding the 1/3, how much a person gets. And then you can figure out how much the other 2 get. They're going to get 20. So this piece is 10 and this piece is 20. And which piece did they want? They wanted GD. So that's 10. Then look at this piece. Okay. Now they're saying that the 2 people thing is 6. Okay. Now they're saying 6. Well, if 2 people get 6, how many does 1 person get? 3. You just cut it in half, right? Because if 2 people get 6, then they get 3 and the whole segment is 9. What did they want? They wanted BF. They want the whole segment. So altogether, there are 9. Sorry, I skipped AG. I went straight to BF. AG, now they want this piece. Okay, and all we know there is that GE is 4. So now they're giving you the individual 4, and they're asking you to find that. Well, if everybody gets 4, then they get 4 and they get 4. So this is 8. So this piece is 8. That's how you do it mathematically. Just cut it into 3. You figure out what the 1/3 is. And then the other part is twice that. Okay, so if this is 4, that's 8. If this is 3, this is 6. If that's 10, that's 20. Okay. Now, here's one for you to try. Feel free to stop. Okay, I'm going to write on it now. VU is 10. So right away, look, if VU is 10, hopefully you guys can automatically just fill in that this piece is 20. Why? Because if the one piece there, this is twice of it. Okay, that's what's so unique about the medians. VS is 7, which means this is 14. Double that. PT, the whole thing is 21. Take 21 and divide it by 3 to get the one piece. So this is 7, and that's 14. Okay? Note, oh, this is important. Sometimes they give you stuff and they're not drawn to scale. So you can't trust your eyes, especially if it's given to you like that. By the way, though, in the SAT, I believe they try to draw things to scale. And you can actually use some pretty cool little, like, simple tricks to, like, see which pieces are equal. But, you know, it's nice when they draw them to scale. Okay, find PV. What's PV? PV, 14. QV, QV, 20. RS, the whole thing, 21. Okay? All right, take a look here. This is called the mid-segment theorem. Okay? I have not discussed this in class. This is kind of fun. I actually think it's fun, and everybody usually gets it pretty quickly. The mid-segment theorem literally says that if you take the midpoint here and you take the midpoint of this side, then this segment is exactly half of this opposite side segment. Kind of cool. So look, I'm going to do this in other colors. So look, midpoint, midpoint. Cut it in half. That's half of this side. Okay? So it's kind of fun because what they're going to do is they're going to give you one of either the long piece or the short piece. Okay? That's what they're going to do. And then you have to figure it out. So look, they're giving you A. I can't even see anything because I wrote all over it. So let's try this again. So that's the mid-segment theorem. This is a really pretty triangle. I just want to show you what it might look like if you had like a weird looking triangle. Let's estimate. If this were the midpoint, and if I could fold my paper in half, maybe that's the midpoint, and maybe that's the midpoint. See? They end up being parallel. Okay, look. Yeah? And then if this were 100, this would be 50. And if this were 80, this would be 40. And if this were 20, well, come on, never. Okay, if this were 20, this side would be 40. Okay, so that's all you have to do. Suppose AB is equal to 48. It's going to say find, nope, it didn't say find EF. Okay, BC is telling us is 56, and DE is equal to 32. Find DF. DF. Okay, so what you need to be able to do is see which side it's parallel to so that you could figure out which half it is. So do you see how it's parallel to this side? Like this is the base that goes with this mid segment. So this is going to be half of 56. Half of 56 is 28. Okay. Then DE equals 32. Oh, well, yeah, right. AC, sorry. AC, where's A? Okay, AC. So do you see now? You're supposed to be able to see this. AC is parallel to this one, DE. and it's going to be double that. So it's 64. And CF right here, this little one right here. CF is going to be half, because this is the midpoint. It's half of 64, which is 32. All right? So you have to kind of just use your brain to figure these out. I think what this is done with this particular one, but I'm going to jump to this one because I have one more. I don't think I have anything else on this one. No, I don't. I just ran out of room on that one. All right. So you could pause it if you want. Okay. And I'll write now 34 AC is 36 BC 72. Find AB. Okay, AB is parallel to this 34. It's going to be twice that. So it's 68. Okay, DE. DE is parallel to this side, and that's 72. So this is half of that, which is 36. 72 divided by 2 is 36. And BE is going to be half of 68, which is 30. Okay. All right, I hope you got that. Now, I think I have, okay, let me see something. Wait. This is the last one. Sorry, this is the last one. Okay, there's something, no, I'm missing half the, okay, this is another tape. Never mind, I'm missing the pieces. For some reason, I don't have the pieces. I think, okay, it's fine. This will be the first video.